In this question, we're being asked to explain how it is that the coil in this very simple electric motor is made to rotate. And the question makes it quite clear that we need to be making explicit reference to the various different components in the diagram. So let's start off by talking about current flow, because that's one of the essential aspects of making a motor work. And let's talk about the way in which the current is flowing. And obviously the current is supplied by the power supply. So let's start off by saying that current flows from the power supply and it flows around the coil of wire. Now, this is a very simple motor, so it's only got one coil, but let's talk about the way in which current is flowing along that. And let's be clear about the direction. The coil sits in a magnetic field because it's in between two magnetic poles. We can see there where the north pole is and the south pole, and we know that magnetic field lines flow from north to south. So therefore we can say the magnetic field flows from right to left in this diagram here. So we've talked about the ideas that current is being supplied and is going to flow around the coil, and that the coil sits in a magnetic field and the magnetic field flows from right to left. Using Fleming's left-hand rule, because this is the important rule which links the field direction and the current flow with the motion, the direction of the current, we're going to focus on the left-hand side of the coil first. The direction of the current being out along the left side of the coil means that, and we can use Fleming's left-hand rule here to identify the direction of the motion, means that there will be an upwards force on the wire. So we've used Fleming's left-hand rule. We've said the current is flowing along in this direction here, along the left-hand side. The magnetic field is across like that. And in that case, what will happen is that there will be a force vertically upwards on that side of the coil there. Now, of course, the coil has another side to it as well. So we also need to refer to what's going on the right-hand side. So the current flows back along the right-hand side of the coil. So obviously that's in the opposite direction. It's now flowing towards the power supply there. So we can now say that the force will be downwards, because if the current's in the opposite direction, the field is the same. So that means that the force then is going to be downwards. This means that the coil rotates, and we can talk about the direction on this. The coil rotates in a clockwise direction, and that's a full and detailed answer. It's important with this that not only do we get the correct points in there, but also that they are in a logical sequence. So we've talked about the current flow, we've talked about the magnetic field, and we've talked about the way in which Fleming's left-hand rule uses ideas about both current and magnetism to predict the direction of the motion.